All right, so we're going to finish up our discussion of chapter 3 here. We're taking a look at a heating curve, which is where we're going to plot what happens to a sample when we start to heat it from a really low temperature all the way up to a really high temperature. So we're going to be looking here at a sample of ice at a really cold temperature and looking to see what happens to its temperature when we start applying heat to the system. So on the y-axis, we're going to record or monitor the temperature in degrees Celsius. And then on the x-axis, we're going to be taking a look at the amount of heat added. And this can be in any unit of heat energy. We'll just say joules for right now. All right, so we're going to start off with our sample initially at negative 40 degrees Celsius, so right about here. So that's going to be our ice at negative 40 degrees C, and we're going to start to heat it. So as we are providing heat to the ice at negative 40, what we're going to see is that the temperature starts to increase. The temperature of the ice starts to increase as we keep adding more and more heat to it, until eventually we get to a point where the temperature stops increasing and it actually stays constant, even though we keep adding more heat to the system. And when we get to that point, what we've actually reached or achieved is the melting point. So right about here would be about 0 degrees Celsius, and that's the melting point of H2O. And at that point, what we're going to have is our ice starting to melt into water. So we're going to have, at this point here, a mixture of ice and water. So all the heat that we add to the system goes into converting the ice into liquid water. So we keep adding more and more and more heat to the system until now we get to the point where all of the ice has melted to water, and now the more heat we add goes to increasing the temperature of the water. Right? So we add more and more heat, the temperature of the water increases until we get to the point where the temperature now stays constant, and at that point we've achieved, or we've reached, the boiling point of H2O, and that would be 100 degrees Celsius. That's our boiling point of water. So at that point we've started to convert now the liquid water into gas. So we're going to have, at this point, we're going to have liquid and gas present. So all the heat that we keep adding to the system goes into converting the liquid phase or the liquid state to the gas phase. So we add more heat, the temperature stays constant until we get to the point where all of the liquid has been converted to gas, and we keep adding more heat, and now the temperature of the gas starts to increase. Right, so as we plot the change in temperature as a function of heat added, what we end up with is just this general type of a graph. Even though it's not a curve, right, we do call it a heating curve. And there are several things that we can note about this heating curve. The first are what the different regions represent. So from the initial standpoint to that first plateau, this region here was where the temperature of the ice was increasing. And then we got to our plateau, and the plateau represent a phase change, right? So this is the flat region here, and that represents the phase change, or this change in state from, in this case, the solid to the liquid phase, or the solid to the liquid state. And at that part of the heating curve, the temperature remains constant, right? So there's a plateau at the phase change or the change in state. After we've converted all of the solid to liquid H2O, then the next region of the graph that increases here, that's the region where the temperature of the of the water increases until we get to the boiling point right about here. And at that point, we encounter another phase change. So write it underneath actually. So at this point here, there's a phase change. And now the change that's occurring is from a liquid to a gas. And again here, the plateau tells us that the temperature remains constant. All right, and the last region would be after all of the liquid has turned into a gas, now we have the temperature of the gas is going to increase. In this case, it's steam or water vapor that we have. So we're seeing the change in temperature as a function of heat that's added to the system, and that is our heating curve. Now we can look at this process in reverse. So for example, we can start off with steam at a really high temperature and then cool it down, right? And we're going to see the same process happen, but now in reverse. So as we cool it down, we'll see the temperature of the steam start to decrease until we reach the condensation point of steam, which is at 100 degrees Celsius. The plateau represents the phase change between liquid water and steam, which is the gas phase. And we keep removing heat until the point where we've converted all of the steam into water, and now the temperature of the water is going to decrease until we encounter the next phase change, which is the freezing point over here, where we're going to have the phase change between liquid water and solid ice. So we keep removing the heat until all of the liquid has turned into the solid, and then at that point, if we keep removing the heat, the temperature of the ice starts to decrease, right? So this is just the opposite of a heating curve, and it's called a cooling curve.